1.3 Compound interest present value. So let's just take a moment to talk about what exactly a present value is. Present value and principal have a lot of commonalities. It's just the way that we talk about present value is if we're given a future value, present value is how much do we need to invest right now. So what does our principal need to be right now in order to achieve our financial goals? So let's just take down a definition here. Present value is the amount that must be invested right now to result in a specific future value in a certain amount of time at a given interest rate. So you guys know the compound interest formula. Let me just remind you of it. A equals P, where A is the future value, P is the principal or present value, 1 plus I to the N. So the question is, how can we use our sweet algebraic skills to rework the compound interest formula to get the present value to solve for P? The secret is just isolating that P. So if I were to isolate this P, I'm going to divide both sides by 1 plus I to the N. So what we result in is P equaling A over, sorry about that, 1 plus I to the N. And that's it. So let's use this formula to help us out in the first example. Actually, first and only example. So Sabrine is 20 years old. She has inherited some money from a relative, and Sabrine wants to invest some of the money so that she can buy a home in Coaldale, Alberta when she turns 33. Whew! Life goals. She's got her life down pat. She estimates that she will need $210,000 to buy a home. So how much does she need to have now to invest at 7.5% compounded annually? Whenever we see compounded annually with compound interest formula, we kind of do a little bit of a happy dance because the I value is just divided by 1. Whereas if it was compounded quarterly, we would have to divide by 4. I digress. Question B, or B part, what is the rate of return for her investment? And C, how would her rate of return change if the interest rate decreased to 6.5% but was compounded quarterly? Dun, dun, dun. So, let's start with A. How much does she need to invest now in order for her to attain her goals here? So I'm just going to rewrite this formula. P equals A over 1 plus I to the N. Now, what are we going to substitute for P? Well, we don't know. We want to figure out what she's going to invest now. What do we substitute in for our A value, though? We know that she wants to come out with $210,000. So that's our future value. What's our I? Our I is our annual interest rate divided by how many compounding periods there are per year. It's compounded annually, so there's 1 compounding period, and our decimal is going to be 0.075. We can say over 1, but we know that anything over 1 is just itself. And our N, our number of compounding periods. We know that we multiply by 1 because there's 1 compounding period per year. Let's see how many years she is going to actually be invested. So the difference between 20 years and 33 years is going to be 13. So we're going to be investing this amount for 13 years. 1 times 13 is da 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 da. It is 13. So now that we have our A, I, and N value, let's plug it into our formula. So the A is going to be 210,000 divided by 1 plus not I, but 0.075, and not to the N, but to the 13. When we plunk this into our calculator here, we're going to get 82,000 and $18.02. I'm going to put a box around it because that's my final answer for A. So that means if she would invest $82,800.02 right now in 13 years at a 6.5% compounded annual interest rate, we would get $210,000. Great. That's really great. So let's figure out what her rate of return is. B. Rate of return. If we remember, it is going to be our interest over our principal. Oh man, this thing is getting all weird on me today. Sorry about that, guys. Okay, so our interest earned is going to be the difference between 210,000 and what we initially invested. So 210,000 minus 82,1802 all over the principal, which will be 82. Oh, sorry, no decimal there. 82,018.02. We get to here to $127,981.98, all over $82,018.02. So we get here, when we divide these things, the rate of return is 1.56041, or we can express it as a percent. So the rate of return is 156.041%. Either one is appropriate, but if you give this answer, you must follow it up with a percent sign. Oh man, C part is a spicy meatball. How would the rate of return change if the interest rate decreased from, decreased to 6.5%, but was compounded quarterly? Well, guess what, guys? We have to do this whole A part and B part all over again, which is fine, but it's a little bit of a longer question then. So let's look at C. So first things first is we need to figure out what her new present value is going to be. So we say present value is A over 1 plus I to the N. We know that our future value is going to be the same, but our interest rate per compounding period is going to be different. Okay, it's going to be 0.065 divided by, and since we're compounding this quarterly, it's going to be over 4. The N is going to be, we're going to multiply it by 4 because there are 4 compounding periods per year. But here's the thing, guys. There's still just 13 years. So 4 times 13 is 52. So let's plunk this back into our formula here. So we have 210 for our future value. And then we have 1 plus 0.065 all over 4. To the power of 52. I'm just going to simplify the denominator a little bit. So it's going to be 210 all over 1.01625 to the power of 52. Just going to extend that there. So I come out with 90,821.83. Let's pause for a moment. Our interest rate for this is going to be less. So that means you need to have a greater initial investment, a greater present value, or a greater principal to invest to get the same amount of money at the end of it. So let's just pause for a moment. Does this make sense? Yes, it does. Even though the compounding periods are more, it will not make up for that difference. So now what we're going to do is we're going to copy exactly what we did for B. Rate of return equals interest. Ooh, forgot that N. Over principal. So the interest is still going to be 210,000 minus, but the present value that we just calculated, so 90,821.83 over the principal, which is 90,821.83. So when we do that, we get $119,178.17 in interest. Let's pause for a moment. Does it make sense that there's less interest if we have a higher principal? Yes, it does. All right. Just going to move this up. So we get our rate of return of 1.31222, or we can express it as a percent. 131.222%.